Assalamu alaikum dear students. We are going to discuss the topic of elevator and Edwards machine. It's the lecture of third chapter of ninth physics. The elevator is a practical example of Edwards machine and which two weights and the passengers are, and the counterweight which is going up and down with that of the box, and which the passengers are traveling up and down. It's a practical example of Edwards machine, that the supporting cable and elevators passes over a pulley and then back down to a heavy movable counterweight. Gravitational force is acting downward and the counterweight create tension in the cable. So just like as we have discussed in the Edwards machine, the same acceleration and tension in the string creates. So the mathematical form of and then when the here we are going to discuss only the first case, that when the elevator is going up, when the elevator is going up, then in that case tensional force will be greater than that of weight, counterweight, or you can say weight counterweight. So for elevator we are going to find the tension. So as we have discussed earlier, that it's a practical example of that of Edwards machine. So by using that mathematical forms of tension, we can derive the tensional force for that of elevator. That we know that when the tensional force is greater than that of the weight of the counterweight, greater than that of the counterweight when the elevator is going up, then it can be find it out by that the net force acting on that object, the net force acting on in such a situation will be the difference between these two things. So the net force, according to the Newton's cycle, net force, when the net force acts on a body, then it produces some acceleration in the motion of that object. So that will be equals to ma equals to tension minus w equals to mg. Now the net force acts on a body, that for example it's m1, and the acceleration has been produced in that of m2. The acceleration has been produced in that of m2, that when the object is moving up, that m2 is less than that of m1. In such a case, that the tensional force will be equals to m1a m2a, or you can say that is the tensional force will be equals to m2a plus m2g, m1 or m2, and both the situation we consider that m2 plus m2g. Now here weight of m2, and it's the acceleration which has been produced and that of due to the net force, so that will also be m2a. So putting the values, that tension equals to m2a having value m1 minus m2 divided by m1 plus m2 multiplied by g plus m2g. Now this implies that taking common g, so we will get the value m1 m2 minus m2 square plus m1 m2 plus m2 square. We have taken common g divided by m1 plus m2. m1 square will be cancelled with that of m2 square will be cancelled with that of m2, and the tension for the elevator will be equals to m1 m2 and m1 m2, that will be equals to 2m1 m2 divided by m1 plus m2 multiplied by g. That is the mathematical equation for that of the tensional force of the elevator arrangement. Dear students, if you are facing any kind of difficulty on such topic, then your response will be highly appreciated. Thanks for watching.